Okay, so in this lesson, we're going to continue talking about multiplying radical expressions. And so the directions would say multiply, but remember when you're multiplying radicals, you also need to simplify if possible. So even though it says multiply, you have to simplify your answers as well. So let's look at number one. Number one, let's suppose we had the square root of 6 times the square root of 24 minus 3. All right, so notice I have a monomial factor times a binomial, so two terms. So I can use the distributive property. And so if you need to write out the whole step. So you would say the square root of 6 times the square root of 24 minus, and then the square root of 6 times 3. Okay. Now remember our product rule for radicals. Whenever you're multiplying two radicals and the indices are the same, in this case 2's square root, then you can multiply the radicands together. So you're going to say 6 times 24 will give us 144. And that's a nice number because remember the square root of 144, well 144 is a perfect square, so the square root of 144 is 12. We're going to come back to that in a little while. And then here, all you can do there is just rewrite this as 3 square root of 6. So remember, always rewrite the radical in the end when you have just this, when you have just real numbers. If there's a variable involved in here, that will be a different discussion. But remember, multiplication is commutative, so you can multiply in any order. Now, don't leave your answer like this because you need to know that the square root of 144 is 12. So the answer is 12 minus 3 square root of 6. All right, so that's number one. Number two, let's suppose in number two I had 6 square root of 2 plus the square root of 7 times the square root of 2 minus 5 square root of 7. All right, so notice I have two binomials. I'm going to use the fall method. And again, be careful. Just write out all the steps if you need to. So basically, you're going to say 6 square root of 2 times the square root of 2, just like this. The outer, a positive times a negative is a negative. So you're going to say 6 square root of 2 times 5 square root of 7. Then the inner, positive is positive. So square root of 7 times square root of 2. And then the last, a positive times a negative is a negative. So we'll be subtracting the square root of 7 times 5 square root of 7. All right, so first, outer, inner, last. All right, let's simplify as much as we can. So you have 6, and then remember, multiplying radicals, if the indices are the same, you can multiply the radicands together. So square root of 2 times square root of 2 square root of 4, but we all know that's just 2. So if you have to write out the square root of 4, then you write out the square root of 4 for right now. Over here, you have 6 times 5 is 30. The square root of 2 times the square root of 7 is the square root of 14. Over here, you have square root of 2 times square root of 7 is the square root of 14 as well. Minus, and then you have the square root of 7. So just like we did here, square root of 4, we're going to write this as square root of 49. Now you could, all of you know that that's 7, so you could have just put 7 there. So simplifying as much of this as we can, this is what we have. We have 6 times 2. These are like terms because they both have square root of 14s in them. And so you have 30, a negative 30 square root of 14, and you have a positive 1 square root of 14. So I'm left with a negative 29 square root of 14. And then right here, that becomes 5 times 7. So 6 times 2 is 12. Keep going further. Minus 29 square root of 14. And then 5 times 7 is 35. And then combining like terms, so you can always combine constants. 12 and a negative 35 is a negative 23. So I get negative 23 minus 29 square root of 14. Okay? And those are not like terms, so don't combine those. You leave that alone. Because this has this term here has a square root of 14 in it, but this term here does not. All right, so that's number 2. Okay, let's look at number 3. Number 3, let's suppose we had this for number 3. We had the square root of y plus the square root of 2x squared. So again, remember what that means. So you have this factor that's being squared. So that means the factor times itself. So go ahead and write it out. You're going to say square root of y plus the square root of 2x times itself. Okay? All right, so let's go ahead and follow this out now. So we have first times first. So we have the square root of y times the square root of y. And then the outer, you have the square root of y times the square root of 2x. And then the inner, you have the square root of 2x times the square root of y. And then last, a positive times positive is a positive. You have the square root of 2x times the square root of 2x. Okay? Now, let's go ahead and simplify each part. So you have this product, so that's your first. You have this product, that's your outer, your inner, and your last. So if you need to write out that step, you write out that step. But many of you know that the square root of y times itself is just y. But if you need to say that's the square root of y squared, then do that. And then over here, the radicals are the radicands. The indices are the same, so just multiply the radicands. So it'll be the square root of 2xy. This, remember, these are the same binomials, so the outer and the inner should be the same. So that and that should be the same. And it is. The square root of 2xy times the square root of y is the square root of 2xy. Now over here, I want you to remember something. If you have to say this, 2x times 2x is 4x squared, then say it. Okay? But all of you know that the square root of 2x times itself is just 2x. So and notice the square root of 4 is 2 and the square root of x squared is x. So this right here becomes y, because y times y is y squared. These are like terms. I have a 1 square root of 2xy and another one, 1. So altogether I have 2 square root of 2xy. And then over here, that's just the square root of 4 is 2, and the square root of x squared is x. So 2x times itself is 4x squared. Notice, though, there are 3 terms. 1, 2, 3. None of them are alike. So that's your answer. All right, so that's number 3. Number 4, let's suppose number 4 had this one, 6 minus 4 square root of b squared. So let's say I had that one. So again, I'm going to do it just like I did this one. So I'm going to rewrite this as 6 minus 4 square root of b times itself. Okay? And then use the FOIL method. So 6 times 6, right? And then the outer, a positive times a negative is a negative. So 6 times 4 square root of b. The inner is going to be the same. So minus 4 square root of b times 6. And then the last, a negative times a negative is a positive. So 4 square root of b times itself. Okay? All right, so let's simplify each part as much as we can. So 6 times 6 is 36. That's the b right here. And then, so 6 times 4 is 24. So I have minus 24 square root of b. And negative 4 times 6 is a negative 24 as well, square root of b. So remember, those two should be the same because these binomials are the same. So the outer and the inner should be the same. And now be careful here. 4 times 4 is 16. The square root of b times the square root of b. Remember, the square root of b times square root of b is the square root of b squared, right? Which is b. So that's 16b. Okay? So this right here is this. All right, and then combining like terms, all I can do is combine these. A negative 24 square root of b and another negative 24 square root of b is a negative 48 square root of b. So I get 36 minus 48 square root of b plus 16b. And that's all you can do there. All right, so that's number 4. Okay, let's look at this one. Suppose we had, let's do this one. Suppose we had number 5. All right, number 5, let's say we had the square root of x minus 4 times the square root of x minus 3. All right, so again, we're going to FOIL. So I have the square root of x times the square root of x. The outer, positive times a negative is a negative, so we have the square root of x times 3. The inner, we have minus 4 times the square root of x. And the last, a negative times a negative is a positive. 4 times 3 is 12. Okay, simplifying this becomes the square root of x squared, right? And then I'm going to just go ahead and rewrite this as minus 3 square root of x, and then minus 4 square root of x, and then plus 12. That should be a x squared right here. All right, simplifying this, make sure you simplify as much as you can. Square root of x squared is x. So that's x. I can combine those. Those are like terms. A negative 3 square root of x and another negative 4 square root of x is a negative 7 square root of x, and then plus 12. And those terms are not like terms. So you're done. You can't combine anything else. Number 6, suppose we had 4 plus the square root of 10 times 4 minus the square root of 10. All right, so again, let's FOIL. You have a binomial times a binomial, so 4 times 4 is, and if you got to write it out, you write it out, but you could just say 16. And the outer, a positive times a negative is a negative, 4 square root of 10. The inner is a positive 4 square root of 10. And the last, you get a positive times a negative is a negative, so you get subtraction, the square root of 10 times the square root of 10. Okay? 4 times 4 is 16. Now, I want you to notice that those are opposites. All right, so don't confuse that with when you did these, that we kept saying those were the same. And those were the same only because those were the same binomials. These are not the same binomials. In fact, what I want you to notice is that the first terms are the same, but the last terms are opposites. All right, so whenever you get that situation, what you're going to notice here is that the out and the inner are opposites of each other. So when you add them up, that's 0. A negative 4 square root of 10 and a positive 4 square root of 10 is 0. And then over here, you have minus the square root of 100. 10 times 10 is 100. But you note that the square root of 100 is 10, so you get 16 minus 10, which is just 6. So the answer is just 6 in that case. All right, number 7. Let's suppose number 7, we had, let's say, the square root of mn plus 6 times the square root of mn minus 6. So it's kind of the same idea here, right? The first terms are the same, the last terms are opposites. So when I do the out and the inner, those are going to be opposites as well. And you're going to notice that. So I get the square root, when I do the FOIL, so I get the square root of mn times the square root of mn, right? The outer, I get the square root of mn times, positive times a negative is a negative. So let's write it like this. Times 6. The inner, a positive times a positive is a positive. The 6 square root of mn. And the last, a positive times a negative is a negative, and then 6 times 6 is 36. Now remember, this right here, you got to simplify this, so you're multiplying two radicals, the indices are the same, so multiply the radicands together. M times m is m squared, n times n is n squared. So this becomes the square root of m squared, n squared. Remember, and I'm going to go ahead and rewrite this as 6 square root of mn, okay, and then plus 6 square root of mn, and then minus 36. At this point, I want you to notice that these are like terms right here, because you both have square root of mn in both terms, but you have a negative 6 of them and a positive 6, so that's 0. And I want you to notice that you can simplify the square root of m squared n squared. So what times itself is m squared n squared? Oh, mn. And so you get mn minus 36. And there's your answer. Mn minus 36. Okay. All right, let's look at number 8. All right, so let's look at, when we do number 8, I want you to notice this. So we have the cube root of x times the cube root of x squared minus the cube root of x. Okay? All right. Now notice that's cube root, not square root. So, but we're still going to use the distributive property. So I have the cube root of x times the cube root of x squared. Okay? And then minus the cube root of x times the cube root of x. Simplifying this, remember I can multiply these because the indices are the same, they're both cube roots. So x times x squared is x cubed. So I get the cube root of x cubed. Minus, and then x times x here is x squared. So I get minus the cube root of x squared. But remember, I can simplify this one because 3 is divisible by 3. So what times itself is x cubed? Well, that's just x. So the cube root of x cubed is just x. I cannot simplify this one because the exponent 2 is less than 3. So all you can do is leave your answer like this. So there's your answer. You're done. Okay, number 9. Suppose in number 9 I had the cube root of a times the cube root of 2a squared plus the cube root of 16a squared. So let's suppose I had that one. Okay. So again, just like we did this, we're going to use the distributive property. So write it out. So that becomes the cube root of a times the cube root of 2a squared plus the cube root of a times the cube root of 16a squared. Okay, so this times this, and then this times this. Okay, simplifying this, I can write this as one radical because the indices are the same. Now be careful. So that'll be the cube root. A times a squared is a cubed. So that's 2a cubed plus the cube root of a times the cube root of 16a squared will be the cube root of 16a cubed. A times a squared is a cubed. Okay, I cannot, I'm sorry, the only thing I can simplify here is the cube root of a cubed. So let's go ahead and write it like this first. So that'll be the cube root of a, I'm sorry, the cube root of 2. Cube root of 2 times the cube root of a cubed. So if you have to do like that, then do it. But many of you can see that the cube root of a cubed is a, so this will be a cube root of 2. Over here, let's do the same thing. So the cube root of 16 times the cube root of a cubed. Okay? I cannot simplify the cube root of 2, but I can simplify the cube root of a cubed because we saw here, let me see if I can get back to it, the cube root of x cubed is just x. So the same idea, the cube root of a cubed is just a. So that's going to be I'm going to put the a in front, cube root of 2. And I'm going to put the a in front so that way it doesn't look like a's with the radicand 2. Plus, now over here, let's think about the cube root of 16. What perfect cube goes into 16? And the answer is 8. So I want you to think about, I'm going to go ahead and do that here. The cube root of 16 is the cube root of 8 times the cube root of 2. And the cube root of 8 is 2, so that's 2 cube root of 2. So this is this. So that's 2 cube root of 2, and then the cube root of a cubed is just a. All right, now the way I'm going to do this, see, some students get confused with the way it's written. So what I'm going to do, see how I have the cube root of 2 in the end? So I'm going to put the cube root of 2 in the end here as well. So I'm going to write this as a cube root of 2 plus 2a cube root of 2. And in in some of our previous lessons, we learned that these are like terms because you have a cube root of 2 and an a cube root of 2 in your terms. You have 1 here, you have 2 here, so altogether you have 3 cube root of, 3a cube root of 2. So 1a cube root of 2 plus 2a cube root of 2 is 3a cube root of 2. Okay. All right, let's look at this one. So let's look at this idea. Now, don't let this throw you off. It's the same idea as we did with 8 and 9. Although you may say, well, that threw me off to begin with. It's not that bad. You have the square root of m cubed n to the 9th times the square root of m to the 5th n squared plus the square root of m to the 14th n to the 7th. Okay. Now again, let's use the distributive property first. So this becomes the square root of m cubed n to the 9th times the square root of m to the 5th n squared plus, and then this times this as well, the square root of m cubed n to the 9th times the square root of m to the 14th n to the 7th. Okay. Now remember, you're multiplying two radicals here. The indices are the same, so you multiply the radicands together. So m cubed times m to the 5th. Remember, we multiply like bases. You add exponents. That's m to the 8th. So it becomes the square root of m to the 8th. N to the 9th times n squared is n to the 11th. Plus, now over here, square root of m cubed times m to the 14th is m to the 17th. N to the 9th times n to the 7th is n to the 16th. 9 plus 7 is 16. Okay? Now, remember, in one of your previous lessons, you learned how to deal with this. So what I would do is I would rewrite this as a product. So I would rewrite this as m to the 8th times the square root of m to the 11th. I'm sorry, n to the 11th. All right, just do it like that. Plus, and then the square root of m to the 17th times the square root of n to the 16th. All right, remember what we did in the past. We said we said, can I simplify the square root of m to the 8th? Yes, very easily, because 8's divisible by 2. So that's just m to the 4th, because m to the 4th times itself is m to the 8th. Now here, I can simplify this because 11 is greater than the index, greater than or equal to the index, but it's not divisible by the index. So let's think of the largest whole number less than 11 that's divisible by 2. And so the answer is 10. So that becomes the square root of n to the 10th times the square root of n. Okay? So I'm just doing little pieces at a time. Plus, and then over here, I can simplify this because 17 is greater than or equal to 2, but it's not that easy because 17 is not divisible by 2. So think of the largest whole number less than 17 that's divisible by 2, and that's 16. So that becomes the square root of m to the 16th times the square root of m. Here, that's easy because the square root of n to the 16th is n to the 8th. 16 divided by 2 is 8, so get n to the 8th. Okay, now let's simplify what we have now. So this is m to the 4th, this is n to the 5th, right, times the square root of n, plus this is m to the 8th, n to the 8th times the square root of m. All right, and that's all you can do. None of these are like terms. Those are not like terms, okay? For one thing, your radicals are different. You have a square root of n, here you have a square root of m. So right away, those are not like terms. And even if they were not there, those are still not like terms because this m has exponent 4 and this m here has exponent 8. And n have different exponents as well. That's your answer. Okay? Let's do one more like this, just to give you an idea again. So let's say we had let's make it a negative. Square root of 3x to the 6 times 5 square root of 15 x to the 5th minus the square root of 3 x to the 14th. Okay? So using distributive property, we're going to have negatives and just write it out like I'm doing. You do too much in your head, you're gonna mess up somewhere. So you have negative square root of 3 x to the 6 times this times 5 square root of 15 x to the 5th. Okay, a negative. Now be careful. See, this is negative. So a negative times a negative is a positive. The square root of 3 x to the 6 times this, the square root of 3 x to the 14. Okay. All right. Now let's simplify as much as we can. So I have a negative 1 here times 5, so that's a negative 5. And then look at your radicals. So I can multiply these as 1 now because the indices are the same. Square root, square root. 3 times 15 is 45. So it'll be the square root of 45. X to the 6 times x to the 5th. When you multiply like bases, you add exponents. 6 plus 5 is 11. Okay. Over here, so that is this. Okay. This is this. Okay, let's talk about this now. Plus, all right, now this, we're going to have 3. Now again, you're going to write this as 1 square root because the radicals, the indices are the same. So just multiply the radicands together. 3 times 3 is 9, so you get the square root of 9. X to the 6 times x to the 14th. When you multiply like bases, you add exponents. 6 plus 14 is 20. Okay? All right, let's go ahead and simplify this as much as possible now. You remember, always simplify as far as you can. So this is negative 5. Now I'm going to rewrite this as square root of 45 times the square root of x to the 11, just like we did here. We broke it down as 2 square roots and we simplified very easily. Same thing here. Over here, that'll be the square root of 9 times the square root of x to the 20th. Okay? All right, now let's see if we can simplify the square root of 45. What perfect square goes into 45 and always choose the largest? Okay, it is 9. So this becomes negative 5 times the square root of 9 times the square root of 5. 9 times 5 is 45. I can simplify this because 11 is greater than or equal to 2, but it's not, 11 is not divisible by 2, so let's think about the largest whole number less than 11 that's divisible by 2. And so that's 10, so that becomes the square root of x to the 10th times the square root of x. So that I rewrote like this. Plus square root of 9. See, 9 is already a perfect square, so I'm just going to rewrite a square root of 9. Well, actually, let's do this because these are easy now. So that's 3, and 20 is divisible by 2, so that's x to the 10th, right? Because x to the 10th times itself is x to the 20th. All right, so that part was easy. That's just this. All right, let's simplify as many of these factors as possible. So negative 5 times 3 times the square root of 5. I can simplify the square root of x to the 10th. That's x to the 5th. Square root of x plus 3 x to the 10th. All right, now let's simplify this now. So first of all, negative 5 times 3 is negative 15. So I get negative 15 x to the 5th. Now, these I have underlined, those are both square roots. So I can write it as one square root. So the square root of 5 times the square root of x is the square root of 5x. And then plus 3 x to the 10th. And that's all you can do. Those are not like terms, so there's your answer. You're done. All right. So those were just more examples of multiplying radicals. So you should have enough problems now based on the 3 lessons on this. So there are 3 lessons on this with all different types of examples. So that should help you understand a little bit better how to multiply radical expressions. So that's the end of this lesson.